Researchers from UCL just reverse engineered the leaked source code of Claude Code, 512,000 lines of production TypeScript. They mapped every module, every system, every design decision. And the headline finding changes how you should think about every AI tool you use. Only 1.6% of Claude Code is AI decision logic. The other 98.4% is operational infrastructure. The model just reasons. Everything else, the permissions, the routing, the compaction, the recovery, runs the show. This paper is the most detailed look inside a production AI agent ever published. Let me walk you through everything they found. Let's start with the core. The entire agentic loop is a plain while true. Step 1. Call the model. Step 2. Run whatever tools the model requested. Step 3. Take the results, feed them back to the model. Step 4. Repeat. That's it. That's the AI part. 1.6% of the code base. Everything else is the engineering that makes this simple loop work reliably in the real world. Think of it like a race car. The engine, the AI model, is a small percentage of the total car. The chassis, the suspension, the brakes, the steering, the aerodynamics, that's the 98.4%. Without the infrastructure, the engine is useless. The permission system alone has 7 modes, not just allow or deny. 7 granular levels of control. And here's the clever part. It uses a machine learning classifier, not the main model, a separate lightweight one, to predict what you're likely to approve based on your history. Users already approve 93% of actions anyway. So instead of showing you endless confirmation dialogues, the classifier pre-approves the safe ones and only asks when something genuinely needs your attention. This is why Claude Code feels fast. It's not because the model is faster. It's because the permission system is smarter. Context management is a 5-layer pipeline. Think of it as a compression engine for your conversation. Layer by layer, it decides what to keep, what to summarize, and what to drop. The goal: keep the most relevant context within the token window without losing critical information. This is why long Claude Code sessions don't degrade as fast as competitors. It's not model intelligence, it's infrastructure intelligence. The compaction pipeline is quietly working in the background, keeping your context clean and focused while you think you're just chatting. The paper identified 4 extension mechanisms, ranked by cost. MCP servers, the cheapest, most modular. They connect Claude to external tools and data. Plugins, bundled capabilities with their own configurations. Skills, reusable instruction sets that trigger automatically based on context. And hooks, life cycle events that fire before or after specific actions. Each mechanism serves a different purpose and operates at a different level of the system. The researchers noted that this layered extensibility is what allows Claude Code to feel like a platform, not just a tool. You're not using a chatbot, you're using an operating system for AI. The Subagent architecture is where it gets really interesting. When Claude Code delegates work to subagents, each one runs in its own isolated environment. Separate Git work tree, separate context, separate tool permissions. They communicate through sidechain files, a messaging system that keeps the main session clean. But here's the cost. Agent teams burn roughly 7 times the tokens of a single session. 7x. That's because each subagent needs its own context loading, its own reasoning chain, its own tool calls. The paper frames this as a fundamental trade-off: parallelism versus token cost. The researchers identified five foundational values that drive every architectural decision. Human decision authority. The user always has final say. Safety and security. Sandboxed execution. Permission gates, audit trails. Reliable execution. Crash recovery. Session storage. Retry logic. Capability amplification. Making the human more productive, not replacing them. And contextual adaptability. Adjusting behavior based on the project, the user's history, and the current task. These aren't just principles, they're implemented as code. Every one of these values maps to specific infrastructure components in the code base. Session storage uses an append oriented architecture. Every action, every tool call, every model response is logged sequentially. Nothing is overwritten. This means Claude Code can recover from crashes mid session. If your terminal closes, if your laptop sleeps, if the network drops, the session state is preserved. You pick up exactly where you left off. The dash dash continue flag isn't magic. It's reading from this append log and reconstructing your session state. This is infrastructure that most users never see but always benefit from. The paper also compares Claude Code with OpenClaw, the open source alternative. Both solve the same design challenges but make different architectural choices. Claude Code optimizes for polish and reliability with a heavier infrastructure footprint. OpenClaw optimizes for transparency and hackability with a lighter code base. The researchers frame this as different points on the same design space, not better or worse. But the key insight remains. Both systems spend the vast majority of their code on infrastructure, not AI. The model is a commodity. The harness is the product. Here's the strategic insight that matters. As frontier models converge, Claude, GPT, Gemini all approaching similar coding capability, the model becomes less of a differentiator. What separates products is the infrastructure around the model, the permission system, the context management, the extension framework, the crash recovery, the session continuity. This is why Claude Code feels different from Codex or Cursor, even when the underlying model quality is comparable. The 98.4% eyes the product. The 1.6% is interchangeable. What does this mean for you? Three things. 1. When you're hitting limits or getting bad outputs, the problem is usually infrastructure configuration. Your Claude.md, your context size, your permission settings, not the model itself. 2. Skills, hooks, and MCP servers are the highest leverage improvements you can make because they extend the infrastructure, not the AI. 3. If you're building AI products yourself, spend 98% of your engineering on the harness. The model is the easy part. Making it reliable, safe, and useful in the real world, that's the hard part. Comment, harness, and I'll send you the complete architecture breakdown with every system mapped out. Both my Claude Code and Codex guides are in the description. They're the playbooks behind everything I build on this channel. Subscribe for more deep dives that go beyond the surface. See you in the next one.